Hi everyone, we're going to look at lattice multiplication next. And lattice multiplication can be used with very similar to the box method that we're going to be looking at a little later. Lattice multiplication is something that is going to be likely quite new for a lot of parents. This was very new to me when I was in university, but it's kind of a neat method and students quite like it. So we'll try out a question, maybe 56 times 32. So 56 times 32. So we know the traditional algorithm. We're going to look at this one a little bit differently. We are going to break down the parts of it to look at this number as 50 and 6 and 30 and 2, like we would be for the box method. So 50, 6, and 32. So the main difference here, and you notice this already, is that we set it up quite a bit differently. So we need to look at this as just the digits. So what I'm doing right now is I'm dividing my workspace into 4 sections. So this is a little easier. Students have told me that they find this easier to organize. Rather than the traditional method, we can, when we're carrying numbers over, to remember what we need to add to what. This is just a different way of looking at that. So what I'm going to do, and this is going to seem a little bit out to lunch for a couple minutes, is I am dividing this all into sections. Okay, so I've made diagonal lines across just to show you what this looks like. So we're going to choose one box at a time that we're going to go through. I'm going to get started with the bottom right, just because that's generally where we start when we're doing the traditional method that a lot of us were familiar with. So for this particular one, we're looking at this box, and just like a grid, we're going to look up to the 6, which is right up here, and to the 2. So let's see if this will allow me to do this. We're going to look up and over. So this box is going to be multiplying 6 times 2. So 6 times 2 is 12. Now, the reason that this box is divided is because this is going to break it down from the tens column to the ones column. So instead of writing 12, we're going to write 2 and 1. That means we have 1 10 and 2 ones. We're going to look up at the next one. Kind of the neat thing about this is it really doesn't matter where you start because you're going to get the same answer regardless. So in in this top right-hand box, we're multiplying the 6 and the 3, which is 18. So these diagonals are important for us to make sure that we have them all lined up. I'm going to get rid of this underlined part. It's going to start looking confusing. Next one, we can look at this one. So we go up and over. 5 times 2 is 10. And then finally at the top, we have 5 times 3, which is 50. So what we've actually done is multiply digit by digit. We like exactly that we would be doing with any other strategy. However, we just need to finish this up. So what we need to do for the last part is to add the diagonals. So we're going to start on the bottom left and add. So 2 is all by itself. There is nothing on its diagonal, so we have a 2. Going to look at the next one. We have an 8 and a 1, which is going to go with a 9. Oh, no, I'm good. Nope, I was right. Sorry. 8 and a 1, which is 9. The next one we have is a 1, a 5, and a 1, which gives us a 7, and then finally a 1. So we take these and we move them all down for 1,792. Now, this one looks extremely confusing. As I'm looking at it right now, I'm going to erase everything and I'm going to show you another example of it. This time I'm not going to use these arrows. So I'm going to get rid of all of this and we'll try it again. And like I said, this one, once you kind of get the hang of it, students really like this one. So once they get the hang of it, a lot of times they will choose this one when they get to choose a strategy to multiply. So we'll try something a little easier. So 22, 20, and 2 times 30 and 3. Whoa. I'm going to make that box. And divide the 20 and the 2 and divide the 30 and the 3. I'm going to switch colors. And I'm going to draw diagonals. And hopefully this solid line will help so it doesn't look quite as confusing. So we'll start at the bottom right again. So we have 2 times 3, which is 6. We don't have anything in the tens column because it's just 6. So we can put a 0 there for a placeholder. I'll go up to the next one. So I'm looking at this one. So 2 times 3 again, 6. 0 as a placeholder. We'll look at this 2 times 3, which is 6. And our final one, 2 times 3, is 6. Okay. So I'm going to change colors again, just so we can look at these diagonals a little bit. Hopefully this will be a little clearer. So 6, we're adding the diagonals, so it's just 6 on its own. In this section, we have a 6 here, a 0, and a 6. So that's 12, just like we would be doing when we're adding. We're going to bump that 1 up here, so we're going to do some carrying. So 6 and 0 and 0 and 1 and 7. And then 0 is all by its lonesome, nothing on its diagonal. So we have an answer of 726. What I think I'm going to do here is stop this recording, and because it is getting a little long. So I'm going to post another one that'll be called Lattice Multiplication Part 2, where I do a couple more examples, because this one, like I said, is confusing, but it's a very neat way to look at multiplying. So see you then.